Hello, everyone, and welcome to statistics, this last topic in our class. And usually I would start talking about probability first before I move to statistics, but those slides are mainly for definitions. We're not going to be talking about technical things till the next section. So section 12.1 is, again, just basic definitions. So statistics. So what is it? What are we going to learn in this? And later on, we're going to be talking about some misuses of statistics. Unfortunately, yes, statistics can be used to lie. Like they say, there are two types of lies that we know when someone lies, and also the other type of statistics or the other type of lies is doing statistics. I don't know if that is a very solid statement or not. But usually when you have, credible institutions doing statistics, most likely the results obtained by those institutions are not misused. They represent they are a good representation of the population. So what we learn upon completion of this section, we'll learn how sampling is, or sampling techniques, or how we take samples, because unfortunately we cannot, let's say if you want to do some research or publish some statistical research or data on the income, for example, of employees of let's say Microsoft. Well, the best way to do this is to talk to every employee in Microsoft. But since this company has a lot of employees, maybe thousands and thousands, well, then you take just a sample. But taking a sample in itself, there is an issue. So how do you actually take a sample? So we'll be talking about the different type or different techniques for sampling. And at the end, we'll be talking about a little bit some of the misuses of statistics. So statistics in general is the science of making sense of data. That's what it is. You collect data, you gather data, and then you work on that gathered data, and you make predictions or inferences. And data is obtained in an experiment or by collecting data from a sample. There are two branches of statistics. Well, descriptive statistics is concerned with the collection, organization, and analysis of data. Just that it speaks, this section speaks for itself. And inferential statistics is concerned with making, from the sample, from the data that you work with at the experiment, are you going to, or when you have inference, when you have predictions from the data that you collected, to infer from studying just that sample. The person working in statistics, the main interest lies on drawing conclusions and possible outcomes through observations of only a few particular events. So that's like from sampling, again, it goes back to the sampling from sample, then drawing conclusions to represent the whole thing instead of just a sample. So the word population statistics does not mean necessarily people. It could be people, it could be, I don't know, it could be animals, could be computers, could be anything. So they use this term here, is the substance that you will be studying when you do your statistics project. And of course, the sample includes some of the items of the population. Well, when you draw a conclusion from a sample, it does not mean that your conclusion will always be correct. So there is always room for error. And when you take a semester-long statistics class here at Valencia, we have, I think, 2 of them, but the main one is STA 2023. You will learn those techniques, and when you do those inference techniques, then there's always a discussion of an error that could be associated with the conclusions that you draw from your statistical results. So, okay, well, the types of sampling, you have a random sampling. Really, the word random here means that there is no pattern, there is no, there's nothing that you implement to select your items from the population. And that could be tricky and sometimes impossible to do. A systematic sample is a sample that is obtained by selecting a random starting point, right? For example, you say, okay, I'm going to start, let's see if you're talking collection data about population or workers in a company. It says, well, you start with a worker, and then let's say you skip 7 workers, and then the 8th worker, you talk to that worker or you collect the data of that worker, and then you skip 7 workers and so forth. So this is called systematic sampling. A cluster is sometimes referred to as an area sample because it is frequently applied to, some specific places. Essentially, the sampling consists of random selection of groups of units. We'll have an example of this one here. A stratified sampling involves dividing the population by characteristics, for example, race, religion, income, and so forth. And this is called stratified sampling. Convenience sampling, because it's easy, it's less costly when you collect your sample. For example, let's say you want to have an idea about, I don't know, something that is nationwide, but of course you cannot travel. Let's say you don't have the means or the cost of the money to travel to Boston and to San Francisco and so forth, and you talk only to people in Orlando. Well, why would you do that? Just for convenience purposes. And of course, this is very tricky because it can be extremely biased. So you cannot just, the data that you collected from people or from workers in Orlando, you cannot use that and says, well, this is going to be the case for all workers nationwide. And this is again known by convenience sampling. Well, here is an exercise. It says every 20th soup can. So the population is soup cans, right? So every 20th soup can coming off an assembly line is checked for defects. So what type of sampling is this one here? Well, this is systematic, right? Every 20th. So you take the first 20th and then you skip, you pick that and you skip 20 and you pick the one after you skip 20 and so forth. This is systematic sampling. Like I said, every 20th item is selected. Here is another one. It says a gift. Yeah, well, I should not have showed you that at the end. So a gift of $50 or a gift certificate of value $50 is given away at the annual bankers convention. Tickets are placed in a bin and all the tickets are mixed up. So then the winning ticket is selected by a blindfolded person. Well, what type of sampling is this one here? Well, this is random sampling because there's really nothing that, this is nothing really that mention how the tickets are picked or placed and so forth. So each ticket will have the same probability to be drawn. Children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools is selected. So this is mentioned the geographical place here. All the children from each selected school are included in the sample. While this is cluster type sampling, it's as clear as this one here. So here, the random sample that you create here is of geometrical areas, so that the ones that you selected. Let's see another one. The 50 people attending a zoo are asked they support an increase in tax to support a zoo expansion. Well, this is very biased. Well, you go to a zoo and you talk to people about zoo. Well, that's for convenience, right? So this is a convenience sampling example. So the sample is selected by picking data because it's easy. Like I said here, well, because easily obtainable. He says the first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. Well, that is fishy right here. While all registered vehicles in the state of California are classified according to type, subcompact. So kind of you you create categories here, or some compact, mid-size, full-size SUV and truck. So, and a random sample of the vehicle from each category. Well, this is stratified sampling. Yeah, so usually I think if I have to, because I'm not too, I would say, knowledgeable as sampling techniques, but the stratified sampling techniques, if I have to guess a little bit here, is to make sure that you have a better representation of the types of the vehicles here in this example. Because if you don't do that, you may end up with having most of the vehicles picked are SUVs, let's say, and that could not be leading to a good representation of the population. Okay, so now misuse of statistics. There's a lot of them, a lot of misuse of statistics. So especially when it comes to advertisement, you know, people or companies will advertise things, yeah, but sometimes those advertisements can be misleading. So let me give you some examples of that. So it says here, 4 out of 5 dentists recommend sugarless gum for their patient who chew gum. Well, you may say, well, there's nothing wrong with that. But if you really look closely here in this example, first of all, how many people were asked? How many doctors or dentists were asked? We don't have any idea. Did they just talk to 5 of them? That could be not a very good representation. And the second thing is this advertisements that is not talking to those who say don't recommend gum at all, right? So they're talking only to those because maybe 1 out of 100 dentists recommended gum. You know, I hope that you understand what I'm trying to say here. So out of those minority, yes, we have 4 out of 5. But the majority of dentists, it says, for example, they don't recommend gum at all. So if that's the case, then this is really a misuse of statistics. So if I read this, it says, oh gosh, the dentists are recommending me to chew sugarless gum. But the reality is what? I am not encouraged to do any gum at all. Well, as you can see here. I mean, there's nothing wrong with the statement in itself. It's true, but it is misleading. So it's another misuse. Here's another one. It says in the advertisements of golf balls, a driver golf ball is hit, another brand golf ball is hit in the same manner. We are told that the driver golf ball travels farther, and we are supposed to conclude that the driver golf ball is better golf ball. Well, it does not mention the number of times, of course, just like the previous example. It does not tell you how many times this experimentation took place. And there's no mention of the wind speed or direction. So that could, of course, in golfing, that will change the whole game. That will change the whole conclusion. That no 2 swings are identical. Maybe the 2 swings are done by 2 different people. I don't know. And that the ball may land on a rough or smooth surface. That also, you know, so those these are all possible sources of bias. And on and on and on. So same thing. In statistics, sometimes vague and ambiguous words can lead to misuses of or misinterpretations. And the word average is one of them. It's in statistics, we are going to see we don't have just one type of average. There are different types of average. A mean is an average. The average, as we all know, it's add all the numbers, let's say, and divide by how many of them. That's one type of average. The median is another type of average. If I say, for example, I have a class, the average is 50, right? You may say, well, my students are doing very poorly. But if I tell you, well, that class had only 2 students, one scored 100 and the other one didn't come to class, he got 0. So does it mean that the average, I didn't lie, the average is 50, but it doesn't mean anything. So again, the average by itself might not be of any value in some situations. So we need the sample size, we need other things. And also we need to mention what type of average are we talking about. And we're gonna see later on that those averages are done differently, are calculated differently. They're not the same. Here's another example. During contract negotiation, it is not uncommon for an employer to state publicly that the average salary of its employees is $45,000, but the employees union state that the average is $40,000, which who's is lying? Probably none of them is lying. Actually, both sides may be telling the truth. Each side will use the average that best fits its need to represent the case. This $45,000 could be the mean, let's say, and $40,000 could be the median. So both of them are averages, so nobody's lying. But of course, a non-informed consumer or non-informed consumer of this information is the one who's going to take the hit. Advertisers also use average that most enhances their product. That's, of course, we know that. Consumers often misinterpret this average as the one with which they are most familiar. Another word is largest. Well, for example, Harding claims that is the largest department store in the United States. What largest in what? In terms of, it could be just in terms of employees, the number of employees working for Harding's. Harding has the highest number of employees, or it could be, well, largest of what? So that could be another misuse right there. Is it largest in terms of acreage, number of stores, outlets, I don't know, sales? Another example, a disinfectant manufacturer claims that the product they manufacture kills 40,760 germs in a lab in 5 seconds. Right, well, that tells you in a lab. So are the circumstances of the lab same thing as outside? And it says to prevent colds, use this product A. Well, and those germs, are they related to cold? So they are not lying. Yes, that product kills 40,000 something germs. Probably those germs, none of the germs happens to have something to do with cold. Yeah. Yeah, and so and on and on. So I'll let you read those slides. It's pretty much the same kind of like, I hope that you get the idea. Is just the sad side of statistics is it can be misused. So I'll jump to something, to graphs. Let's see here. I'll let you read those slides and pause them and read them. Graphs and charts, because statistics is not just presenting data in terms of numbers, but or in terms of writing paragraphs, but it is widely known that within statistics, people represents their finding in terms of charts or graphs, and those can be misleading. And then look at this example. These are the same. Well, these are the same, but this graph may look to you, well, it's going up faster than this one. Even these are the same. What they did here, they played on the scale. You see that wiggly line here that says, well, the unit is 25. So, well, the unit is 5, it goes by 5, but we started at 25. So if they put a straight line, that would be, of course, incorrect. That said, well, they kind of like they compacted from 0 to 25. So here they didn't do that. So 0, 5, 10, 15, 20, 25, and so forth. This is more, I would say, more honest than this graph here, even though they're the same graph. Well, they did the same thing here when those charts, yeah, those column charts or rectangular charts or whatever they call them. So you see here, they says they jumped So the unit here is 5, but the unit here is 20. So if you look at this graph here, the one I'm hovering over, you would say, wow, there's a huge jump between 2009 and 2010, which is not really the case because the unit is just 5 and they represent this. So the trick again is in this wiggly line here, but this is more honest than the first one. Here is another misleading picture. So suppose that this year you make $1, next one you make $2 profit, whatever that is. Well, yeah, so from this year to this year, there's a jump of $1. But if you look at the area represented, the brown area versus the turquoise area or the blue, light blue or greenish area, this is a 1 by 1 square, which is the area is 1, but this is a 2 by 2, the area is 4. So if you really focus, if you're a visual person, focus just on the area, you may say, oh, it jumps from this much to this much, which is a big lead or a big jump, which is not the case. It's only $1 jump, not $3. Well, this is even worse if you represent things with 3D. So a 2 by 2 by 2 is 8 versus 1. So here's another misleading situation. If you add up all these percentages, 42% and 49% and 37%, 15%, this is not 100%. So let's see, this is the top 6 reasons Americans say they use the internet. So more than 100%. It's not nothing, well, because you may have some overlaps. For example, you may have people who gather information about services are also gathering information to do research. And so that's why you have more than 100%. So actually that's 183%. So a graph other than a circle graph should have been used to display the top 6 reasons Americans say they use the internet. So again, as a consumer of statistical results, you need to be careful. So you need to take your time and investigate things a little bit more carefully. But again, this is okay. We need to be also also fair. While despite the examples presented in this section, you should not be left with the impression that statistics is always used to mislead or cheat consumers. Absolutely not. But knowing these things, it makes you a better, I would say, reader of statistical results. That's what we're trying to say here. Well, that's enough for these ones here. So I'm going to put the slides on this. We're going to read about those more. We find them along. But what we need to really focus on as of now is just what is statistics. It's just the science of making sense of data. And to make sense of data, you need data. And this data can be represented or can be obtained using samples. And there are different sampling techniques. And the second thing is that sometimes we have some misuses of statistical results. Okay, well, the next videos or next discussion will be more technical. We are actually going to learn how to make statistical calculations. And we will be talking more about what's called the normal distribution. It's a distribution of data that is widely used in a lot of applications. Okay, until then, you guys take care.